Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi guys, welcome back to our video series on phonetics. In this video, we're taking a closer look at the second phonetic, which is acoustic phonetics, which is the study of the physical properties of speech sounds. We'll talk about how sound waves work, how we measure speech, and why this is important for language learning, technology, and more. Let's get started. So what is acoustic phonetics? Acoustic phonetics is all about what happens to sounds once they leave our mouths. We analyze sound waves to study how they travel through the air and how they are received by listeners. This field plays a key role in speech recognition software, forensic linguistics, and even voice therapy. So, acoustic phonetics focuses on sound waves and their properties, studies frequency, amplitude, and duration of speech sounds, and is used in speech technology, linguistics, and forensics. Let's take a look at how speech sounds move through the air, travels. Yeah, speech sounds are waves moving through air. So actually, when we speak, we produce sound waves. These waves move through the air and create changes in air pressure. Two important aspects of sound waves are pitch and loudness. Pitch or frequency determines how high or low a sound is, like the difference between a high-pitched E and a deep O. Loudness or amplitude, on the other hand, is showing how strong the sound is, or think of the difference between whispering and shouting. Okay, one way linguists study speech sound is through a spektogram. This is like a fingerprint for sound. The x-axis represents time, while the y-axis represents frequency, and the intensity or color shows how strong the sound is. By looking at spectrograms, we can study differences between vowels and consonants, identify accents, and even recognize emotions in speech. Okay, so the key to vowel sounds narrations. Have you ever wondered why the vowels in C and blue sound different? Well, that's because of format, which is the key frequencies that define vowel sounds. The first two formants, F1 and F2, help us distinguish between vowels. Higher F1 means a lower tongue position, and higher F2 means a fronted tongue position. By analyzing formants, we can even tell which vowel someone is saying just by looking at a spectrogram. Amazing, isn't it? Okay, now let's take a look at acoustic differences between consonants and vowels. Vowels and consonants behave differently in acoustic phonetics. Vowels have smooth and steady formant patterns, while consonants show sudden changes in energy. Stops like p and t appear as brief bursts of sound, while fricatives like us and f create continuous sound, continuous noise. Spectrograms then help us identify these different sound patterns. Now let's take a look at the voice onset time, or VOT, which to distinguish sounds. It is VOT, or voice onset time, is how long it takes for your vocal cords to start vibrating after releasing a sound. If you see bat and pat, you'll notice that your vocal cords vibrate earlier for b than for p. This is one way we tell sounds apart. So VOT measures the time between sound release and vocal cord vibration. Short VOT, usually voice sounds like b and d, while long VOT is for voiceless sounds like p and t. That's voice onset time. Okay, now acoustic phonetics isn't just theoretical. It is used everywhere. AI system like Siri and Google Assistant rely on it to recognize speech. Forensic experts use it to analyze voices in criminal investigations. And in language learning, apps like Elsa Speak, I'm sure that you familiar with this app, use acoustic analysis to help learners improve pronunciation. It's amazing how useful phonetics can be, isn't it? Okay, now quick sound challenge. Time for a quick challenge. Listen carefully to these two words. Sip, sip and zip. Sip and zip. Which one is voiced? Okay, if you guess zip, you're right. The Z sounds makes your vocal cords vibrate, while the S sound doesn't. Acoustic phonetics help us understand why some sounds feel different in our mouth. To sum up, acoustic phonetics help us understand speech as sound waves. We use spektrograms to visualize speech, phonetics to recognize vowels, and VOT to distinguish between consonants. This knowledge is key in fields like AI speech recognition, forensic linguistics, and language learning. Pretty cool, right? That's a wrap up on acoustic phonetics. I hope you found this lesson interesting. In our next video, we'll explore auditory phonetics, where we learn how the brain processes speech. See you soon. Wassalamualaikum warahmatullahi wabarakatuh.